Okay, babies, this is going to be 4.1 second video, and we're going to look at our examples for graphing exponential functions. So if you will look at this very first one, we have f of x equals 2 to the x minus 1. So if you will recall from the last video, since the base is bigger than 1, in this case it is 2, I know that my parent function looks like this. It moves up to the right. Okay, so there's more going on here though, because if you'll recall from using transformations in Unit 1, if we have x minus 1, that means that we move to the right 1. So the parent function, because the base is 2, is going to do that, but it's going to move to the right 1. So what would this look like? Well, I know that the parent would do this, all right? So if it's moving to the right 1, it's going to go through that point. So now I've got to draw my graph through that point, just like that. And don't forget to label it. So it is now 1, 1. We're going to talk about that. All right, so my domain, still going to be negative infinity to positive infinity. My range is 0 to infinity. Your range and domain are always going to stay the same unless the graph moves up and down. If it doesn't move up and down, your range will stay the same. Your domain's always going to be negative and positive infinity. All right, x-intercept, there isn't one. Y-intercept. The y-intercept actually changed now because of the fact that we shifted 1 to the right. So technically, your y-intercept, remember, your y-intercept is when x is 0. So technically, it's going to be 2 to the negative 1. What does that mean? That actually means 1/2. So technically your y-intercept now is at 0, 1/2. And this point right here would be called a pivot point. All right, your pivot point of 1, 1. Your end behavior as as x approaches negative infinity, y approaches 0. As x approaches positive infinity, y approaches positive infinity. There is an asymptote at y equals 0. Again, that's going to stay the same all the time unless your graph moves up and down. Decreasing, it is not decreasing from left to right. It is actually increasing from negative infinity to positive infinity. So that's what that would look like. Okay, let's look at example number 2. We have a negative 2 to the x. So again, our base is greater than 1, so our graph is going to climb to the right. All right, and the negative indicates that we are going to reflect across the x-axis. If it was in parentheses, it'd be the y-axis, but it's outside parentheses. There are no parentheses. So we are actually going to reflect over the x-axis. So everything else should be fairly easy for you. All right, I know the parent would look like that. So if it reflects over the x-axis, it's going to do this now. All right, so we just have to read the graph, and this should be easy peasy lemon squeezy. So my y-intercept now is 0, negative 1. There's still not an x-intercept, my domain. Negative infinity to positive infinity. My range, we reflected this time, so it is actually negative infinity to 0. The asymptote is y equals 0. It is decreasing this time from negative infinity to positive infinity. That looks horrible. Okay, it is not increasing the end behavior. As x approaches negative infinity, y approaches 0. As x approaches positive infinity, y approaches negative infinity. Bam. All right, this last example, I actually meant to change this example in your notes and I forgot. So we're going to do that now. It's going to be y plus 1/2 to the x. I needed you to see an example where your base was less than 1 and greater than 0. So that's what we're doing. Okay, so for this particular problem, remember that since the base is less than 1, then my parent function would look like this. Okay, so it would look something like that. Not as messy, but you get the idea. So this time, yes, that tells me what my graph is doing in general, but notice I've got this right here. That means that I have a situation where it actually shifts up 1. So I am going to move everything up 1, so that actually gets moved up. The shape of it won't change, but that means my asymptote also moves up 1. And so, of course, my graph is going to look like that. So the domain, still negative infinity to positive infinity. The range now is going to be from 1 to infinity. There's still no x-intercept. The y-intercept now is going to be at 0, 2. The end behavior as x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches 1. The asymptote, of course, is now at y equals 1. It is decreasing from left to right, and it's not increasing. So hopefully this wasn't too terribly trying. Oh, I did forget to label that. Shame on me. Okay, so that is what your graph would look like.